Anyone have any homework questions for me on 8.3 homework, which is due tonight? Hypothesis testing for one population mean, for population mean. Anyone have any questions?
So I have a quick question. Question 8, 9, 10, and 11, they're the same. So will you have questions like that on the exam?
8, 9, 10, 11.
Yeah, when it gives you like the
It's fine. Let me so everyone was here. So this is 8. This is question 8. Question, you say 8, 9, 10, 11.
Yeah, like they're the same. Would you have questions like that on the exam?
Yeah. Yes.
So can you, like, I need a little bit more. I completed the homework, but some of them with the fail and the reject, like, can you explain a little bit more about that?
Yep. So you want to do 8, 9, or 10? Which one you want to do?
It doesn't matter because they're the same.
They're the same. Okay.
Yeah, they're the same.
I'll just do 10. So
okay.
So just simply that. Yeah, they all look the same. So this is a set of list of earthquake depths, and these are the summary statistic given us the sample size, the sample mean, and the sample standard deviation. Use a 0.01 significant level to test the claim. This is the claim that the seismologist of this earthquake from a population mean is equal to 4.0. So this is the one I highlight is the the claim statement that is very important. So you need to figure out what is your out now and your alternative hypothesis. So when you have an equal, you always test against not equal. So you have equal and not equal. So your answer should be B. And then in order for you to find the test statistic, you have to go to StatCrunch. So you go to StatCrunch. You have to enter all these numbers in. You go under stats, you go under T-stats, one sample with summary. So this is the one that you'll be doing because there's no data given to us. And you just type in the informations provided. So the mean is 4.85. The standard deviation is 4.72. And there are 400 sample size. And then we are doing a hypothesis testing that this is 4 kilometers. So this is 4. And this is not equals to. So this is the hypothesis testing for the procedure. And the T-stat is the test statistic here. So it should be 3.6 in this case. And your p-value will be the next one, and that will be the one next to it.
So when you're doing this, when you're putting in the numbers, you don't change this significant level? Because like, you know how it says like 0.95?
No, we don't. That one is the 0.1 is used when we do the when we compare.
Oh, okay. Because I mean, I've gotten them right, but then I've changed it. I've always changed it.
No, you don't change this. No, you don't change this.
Okay.
So this is the same p-value that we have. So nothing. So the p-value in this case is actually 0 actually, because if you round this into 3 decimal place, the 4 is still not big enough to round up. So it, in this case, will be 0. Okay. So this is the time when you do the conclusion and the decision. This is a time when you use the p-value that you have found in your StatCrunch and the significant level. This is a time that you use it. Okay. So so in order for you to do this, so your p-value, if your p-value is less than your significant level, you will reject your null hypothesis. Reject H0. And then if your p-value is greater than alpha, then you will fail to reject.
Okay, that makes sense. Okay.
So you have to look at the p-value that you found in your StatCrunch, in this case 0, and significant level, which is given in the question, alpha, which is 0.01. And then you have to figure out, are they less than? is this number less than or greater than 0.01? So which one is it?
Less than.
So it's less than, so it's the first one. So this one, so 0 is less. So that means that we will reject the null hypothesis here.
Okay.
So for this case, you will be rejecting. So this is how you pick this, is based on here. So you reject. Now you will look at your conclusion. Again, your conclusion is the same conclusion as your chapter, the 8 that we have, the table. Show it to you.
So it will be significant.
So which is this table. It's the same old table, this table. This is the same table that we used the whole time. So, so what you do here is, first thing first, ask yourself, is this question has equality or not equality? So how do we do is we read the claim statement again. And since this claim statement has a equal, this is the claim statement, so it has equality. So your choices is either the third and the fourth one, because it has, your claim statement has equality. And then you have to look at, since you are rejecting your H0, so and you're rejecting, so we are picking this conclusion to write.
So there is
sufficient evidence to warrant rejection of the claim. So there is sufficient evidence. Now they don't use the word warrant rejection, they say conclude. So in this case, you have to say is not. So this is a negation statement because of the word rejection. So every time you see the word reject or the word not, is a negation, so you have to negate it. So there is sufficient evidence to conclude the original claim. So that means that this is a positive statement. So in this case, you have to write it down that it is not correct. This means that the same as warrant rejection.
Okay, thank you.
So in the test, I would recommend you to just write this down, because in your online homework that you cannot write, you have to follow the system, the way that they write it down. So in the test, it's mostly just you write it down. So make sure you write there is sufficient evidence to warrant rejection of the claim that the earthquake are from a population with a mean of equal of 4.0. So this ... behind is your claim statements that you have even. So you just copy and paste it over here. So I would recommend, because in the test, it's mostly you have to write it out. So I would recommend you to write this out. Otherwise, if you put the word, this should be sufficient, but then make sure this is the word not here because of the word reject. Questions? Yeah, unfortunately, I cannot do a lot with this online homework because it's fixed like this. Sometimes they change the way, which is like, I don't know why. This is what I got from the textbook, and this is from the textbook to your homework. I don't know why they put it this way, but so that's the one that I will point out. And yes, in your test, it will look more like this, where it is mostly you have to fill it in. So when you write your conclusion, make sure you just copy and paste it from here. Okay. Questions? Okay, so we're gonna start chapter 9 today. So what is the difference between chapter 7, 8, and 9 is chapter 7, we are doing confidence interval for one population. Chapter 8, we are doing hypothesis testing for one population. So so this is what we are doing in chapter 7 and 8 is we are doing confidence interval, and we are doing hypothesis testing, but this is only for one population, one group. Okay. Chapter 9 is where we will talk about two groups. So we are doing comparing for two population parameters. So, so this chapter 9, we will combine hypothesis testing and confidence interval together in one session. So when we do two proportion here in 9.1, you are doing both things. You are doing part A, which is the hypothesis testing, the 7 steps that you did in chapter 8. And then part B, you will do a confidence interval, like what you did in chapter 7. So this actually has a lot of work to do because you're doing two things together here in one question, hypothesis testing and confidence interval. But this, so we are doing testing the claim and we are doing confidence interval. And we are talking about two population parameters here. So last time we were talking about one group. This time we're talking about two groups. So if you want to compare boys and girls, Republican, Democrat, left, right, something like that. So you've got two groups to compare. Then you'll be doing chapter 9. And chapter 7, chapter 8 is only for one group. That means everyone. Okay. So if I'm talking about the test, your first test score, your midterm, as a whole, as a general, as everyone, then I will refer to chapter 7 and chapter 8. But if I break that test score into two groups, male and female, and I want to compare who did better, male or female, then I have to look at chapter 9 here. So make sure you guys know when you do my finals. So chapter 9 is for when you got two groups. So that they give you more information, because last time they only give you one mean, one standard deviation, and one sample size. This time they will provide you two, because one is for group 1 and the other one's for group 2. So 9.1 is doing a two proportion. And then 9.2 is doing two mean. As you know, we got means and proportion. But means are very tricky here. One is 9.2 is for independent samples. And 9.3 is also talking about mean, but this is for dependent samples or matched pair. So when you guys, I will explain further more about this 9.2 and 9.3, but first let's concentrate on 9.1, where it's about two proportion. Again, when you talk about proportion, proportion is the same thing as percentage, decimals. So if a question asking for the percentage or the decimals of proportion, the word, make sure that you refer it to 9.1. And this is also for categorical variables. Okay, so make sure you guys know this is for categorical variables. So like male and female, if I break you guys into two groups, and these two groups is male and female, and we cannot talk about test score. The reason why is because test score is not categorical. Test score is quantitative. So that is 9.2, the mean. So for this case, we're talking about, I break you guys into two groups, male and female, and I want to figure out who is more left-handed, lefty. Is that the girl or the guys is more left-handed? So left-handed, right-handed is categorical variables. Or who has more brown eyes, because again, category. So when we talk about categorical variables, we're talking about categories, and you pick one like eye color and your left and right-handed, or that's more, is that more Democrat in the girl compared to the guys, or is that more Republican in the girls compared to the guys? So something like that. So this is talking about yes, no type question, male, female. But we don't do that. Yeah. So make sure we don't do male and female, because we break you guys in male and female already. So we don't want to do male and female. So so this is for two proportion. So so there are in order for us to separate between the first and second proportion, we put 1 is for the first population, and we put 2 for the second population. So if you see 2 means it's for the second group. So the P1 in this case is the population proportion here, okay, for the first population. So this is a population proportion. This is your sample size. This is the number of success. So in this case, if I say, so let's say example in this class, I ask left, and population 1 is female. That means I break into you into two groups, and population 2 is male. So I just figure out how many of you female is left-handed. And let's say I don't have time to count, you guys raise your hand, and I found out there are 5 girls in my class are left-handed. And let's say there are 16 girls in my class, example, okay? Then I do the males. I ask the male group, how many of you guys are left-handed? And let's say we got 6 people out of, let's say 20 male in this case. Okay, now do not just look at the numbers and figure out, oh yeah, male is more lefty than a female. You cannot do that. So because the sample size is different. Okay, so P1 hat in this case is your sample proportion here. So in order for you to find this sample proportion, you have to take the x1 divided by n1. So if a question did not provide us the sample proportion for the first population, you take the number of success over by the sample size. So in this case, it will be 5/16 if the question did not provide us, and then use your calculator to figure out what is that. Q1 in this case is the sample failure. So sample failure in this case is the opposite of number of success. So if there are 5 girls in my class is left-handed out of 16, can someone tell me what is the number of failure in this case? That means how many of them are, in this case, right-handed? Because one success is left, failure is right. So how do we figure out is you just subtract the sample size from the number of success. So in this case, it's 11. Okay, so usually it's going to be the 11 out of 16. So if you want to figure out what is the Q1 bar here, a Q1 hat in this case. Okay, and again, this is all for female, and then you repeat the same thing for the second population, in this case, male. That is the same thing. This is very important. Those students, please pay attention here. How do you know is which one is the first population and which one is second population in your homework or in your test question? Okay, because when you read something, you say, okay, I got male, I got female. Which one is the first? And again, if you switch these 2 around, you will get a wrong answer. So how do we know which one belongs to the first population? You read the claim statement. Usually they have a claim statement. The first one, the first variable will be population 1. Okay, and then the second. So when you read, it says, I want to figure out if female is more lefty than than male. So female comes first, then the first population will be female, and then male comes last, so that will be second. But if I want to figure out if there is male more lefty than female, then male is the first population, female will be the second population. So make sure when you guys read the claim statement, like you guys do the testing, please make sure you know which one comes first. Okay, that first one is the first population, always. Okay, always, for the whole chapter 9. This is how you do it. Okay, and do not forget, if you switch these 2 around, everything you do is all going to be wrong. Okay, we do not need to worry about this pool sample proportion because it's horrible. We do not need to worry about that, so I wouldn't ask you for that. So don't worry about getting that pool sample proportion here. The requirements, there are 2 requirements here. The first requirement is a simple random sample that has to be independent. So there has to be 2 simple random samples that are independent. What is the meaning of independent means? Independence means there are 2 totally unrelated. So that means one group has nothing to do with second group, like male and female. So mostly we don't talk about the one in the middle, female and male. So, and those who are, I know it's hard to do male and female because some of you might not, your gender, you don't, there's so many gender right now, right? So, non-binary and all this gender that you guys have. So mostly, so what we're talking about here is we just talk male and female, for example. So these two groups are independent. Same thing happens when you talk about age group. So between students who are below 21 years old and above 21 years old, that is also independent because you cannot go into two groups. Either you are below or you're above 21 years old. So this is what we call as independence. And then for these two samples, you have to have at least 5 successes and at least 5 failures. So, so for example, is like when we talk about this female example about left, we got 5 females here. And for the male group, we got six of them. I highlight too many. So 6 of them, I should not highlight them. There's my back button. They don't have a back button here. So, so you do not need to, I don't mind all these things. Oh my goodness, Lord, undo it. So I need to undo all these things. Okay, making it worse. So, so the female is 5 girls that is left-handed and male is 6. So that is at least 5 success and at least 5 failures. So that is the second requirement in this case. So there are only 2 requirements in this case. I want to get rid of this. I don't want to. There's no back button for this. So again, you do not need to worry about the formula to find your test statistic. This is a formula that if you watch the video, remember there are videos that I post in D2L that I say watch this YouTube video. They will use this crazy formula to find your test statistic. But as I mentioned to you, since we do StatCrunch, you do not need to memorize that. And what you usually test for, you always test for P1 equals to P2 for H0. So your null hypothesis is fixed. Your first population proportion is the equals to second population proportion. But for your H1, your alternative is either P1 is less than, greater than, or not equal to P2. So again, so this is usually in your claim statement that if they are less than, greater than, or equal to. So, but don't forget your H0 is P1 equals to P2, and for H1 is either less than, greater than, or equals to P2. And if you subtract the P2 over, so this is a little bit of math, like a little bit of algebra here. So if P1 equals to P2, and if you move this P2 over there, so it's P1 minus P2 equals to 0. So these two are exactly the same. Okay, so you can also write your H0, your null hypothesis this way or this way, but this way is a bit more work. But no matter which way you write, it's the same. Okay, so that is the reason why that we usually pick it the first way, because it's easier. This is the way that usually we pick, but if you want to write this way, it's the same. What is this stands for? I will tell you what is this P1 minus P2 stands for. In StatCrunch, you do stats, proportion stats to sample with summary. So unlike text, click on the highlight, a box will appear. Okay, I might try that. Thank you for the Cecilia for that. I need to unhighlight all these things. There you go. Where's my friend highlight? Oh, there you go. I don't know. Oh, unhighlight, you say, Cecilia?
I think you're supposed to press delete once you like, yeah.
I deleted.
Yeah.
Oh, I saw it.
Oh, yeah, the delete. Oh, that too.
Delete.
The delete.
Oh my
Or you
God,
could do it white. That kind of works.
so many colors. I don't know.
Oh, there you go.
One more time. I think I did it too many times. That's fine. So sorry about that. Thank you, Cecilia, for that. So, so in your StatCrunch, this is important. You go here. Now it's not coming up because of my color. Technology, I told you. I want different color. Now they don't give me, oh, there you go. There you go. So let's go to StatCrunch. So so this is what you do here is you go to stats, you go to proportion stat. Last time we do one sample for chapter 7 and chapter 8. This time we will do 2 sample with summary. So this is the one that you will be using. And again, this is for the first sample. This is for second sample. This is number observation. So in this case, if you talk about the girls and the boys lefty, so in this case, there are 5 left female out of 16 female students. And for guys, I have 6 lefties out of 20 males in my class. And we usually, we want to figure out if there is more female, let's say. So this one is the same as P1 equals to P2. That's how your StatCrunch is writing. They are the same, so don't worry. You can, either way is fine with me when you do. And let's say my claim is more female lefty than male. So I will write P1 minus 2 is greater than, because the word more. So I will hit compute. Again, we are using this is the Z. So this is the p-value and this is the test statistic in this case. Okay, it's a Z. So so in my test, I will ask for sampling distribution here. So sampling distribution will be Z. So some of you will ask me, was like, is all proportion sampling distribution is Z and all about mean is T distribution? My answer to you is yes. So that's why when you do proportion in the 9.1 and 7.1 and 8.2, they're all about proportions. The sampling distribution is automatically Z. If you do not know it's Z or T, you can look at your StatCrunch. If your StatCrunch says Z stat, this is Z. And if StatCrunch say T stat, like the one that we did last time, then it is a T distribution. So so make sure you guys, so last time we do is a T, this time we do a Z. Do you see that? So that T and Z will tell us what distribution is it. Okay. Confidence interval, you do not need to worry about doing all this work. It's crazy formulas here. It's the same thing as your just doing confidence interval. So how do we perform confidence interval? You just take back what you have when you perform your hypothesis testing. You go to option, you edit it. So now you will pick the second one. So last time we do this for hypothesis testing. So you just click confidence interval. Let's say the confidence level is 95% and you hit compute. This will be your, your confidence interval in this case, limit, lower limit and upper limit here. So make sure you guys understand this. So you do not need to worry about all these crazy formulas that I acted out here, because your StatCrunch will do the work for you. This is the important stuff in this class, which is right here. This is very important. So so if you guys try to put this, write this on your, for your final, remember you're allowed to have one little cheat sheet. This is the one that I would recommend you do. So what we are doing in confidence interval is we want to see if your confidence interval includes 0 or not. Okay, so if it does not include 0, then we are suggesting that that is a significant difference between the two proportions. Okay, so if it's not include 0, that is significant difference. What happens that it does include 0? So if your confidence interval does include 0, means there will be no significant difference. That is, just put the word no in front. No significant difference between the two population proportion. So what does that mean in this case when I say no significant difference? It means that P1 is equals to P2. Okay, so when you include 0 as no significant difference, means that P1 and P2 are the same. So you can tell by the confidence interval that we found here for the male and female, what you notice here is these are your confidence interval. And since one of them is negative, one of the upper is positive, means you will have include 0 in this case. So include 0 means that when your confidence interval is 1 is negative, usually the lower one, and 1 is positive. So this is usually what you get when you have include 0. So that means this tells us that by doing this testing here, female and male is actually equal. That means that lefty for male and lefty for female, they are equal in this case. Okay, so they're pretty much equal. So that is for. Cecilia?
Can you go back up, please? I would like to see that. How, like, where would you see? I know that you have to do the data, but how would you know if it's equal? What were the number of males?
Because of the lower and upper limit here.
So the number of males that were left-handed, what did the data say?
6 out of 20.
And then females, it was 5 out of
16.
16. So in terms of like, so are we saying that the ratio is the same?
Yeah, that means
because
that
they're not the same amount of people.
Remember, I'm trying to test if female is more than male left-handed, right? But with this result, this is false. The statement will be false. This is my statement, right? My claim statement.
Okay.
So this is my claim statement that female is more than male for left-handed, and it is false. And how can I tell it's false? Is by looking at my StatCrunch. I can do just my limits, and the reason why is because the lower and the upper in this case has 0. So that's why we will conclude P1 equals to P2. Okay. What happens if you get both negative? It can happen when you do your significant level, your lower and upper both are negative, then you can conclude it is the same that this is a significant difference. And you can conclude that P1 in this case is less than P2. Okay. And what happens if both of these are positive? Then you can conclude that P1 is also significant difference here. But in this case, P1 is more than P2. So this is how you figure out by just looking at your limits, upper and lower limits, to figure out are they significant difference or no significant difference. And you can also tell are they equal or less than or greater than by just looking at it. So for this case, we were doing this conclusion, the last conclusion. But if both of these are negative, it will be the first one, means P1 is less than P2. Then if both of these are positive, P1 is greater than P2. So this is something here that I just point out here. These are very important. So if you guys are putting this in your cheat sheet for your finals, this is something, oh no. This is something that I will suggest you to do. Go away. Sorry. I'm going back to what? Okay, so this is something I would recommend. So this is one important thing. There is also the next important thing is to figure out, I don't like this. Next important thing is in your questions. So I just give you a question. So this is a question looks like they only provide you significant level. They did not provide you confidence level. Usually when you want to find confidence interval, I always say find a 95% confidence level, find a 99%, 98 or no 80, something like that. But usually in this case, in chapter 9, you don't have a confidence level. They only give you significant levels. So how do you figure out the confidence level? Is this one. This is the second important thing that I would recommend you. For any, oh my God, why you give me, I don't want all this. I just want, why they keep doing this? So for any one-sided test, either left or right-hand side, the significant level, the confidence level is given us by 1 minus 2 alpha. And alpha is your level of significance. For any two-sided test, then the confidence level is 1 minus alpha. So this is the second important thing. So there are two important things here, especially for your test. So do not miss this follow-up, because this is where a lot of students get, wacky or wrong. And don't forget, we will still use the same thing for mean in chapter 9.2 and 9.3. So make sure you guys know this, okay? And then the third important thing, which is not inside here, which I will put right here, this is the third. So that's 1, 2, and third. So the third important thing is switch population. So what do I mean by switch population? Means population 1 become population 2, population 2 become population 1. So let's say that the confidence interval that we found here is male is the first, female is the first one, and male is the second one, right? This is the confidence interval here. What happens if I switch the population around? Means that now my population 1 is male, my population 2 is female. So this is what happens to switch population. So let's say that population 1 is female and population 2 is male. This is what I got, the confidence interval, the one that we just get here, this number, negative, oh my God, so bad. I wish my screen is, I got a big screen already, but I think I need 2, 0.29 and 0.32. Okay. So what happens if I switch the population around? Your population 1 is male and your population 2 is female. So I'm going to do switch around here, switcheroo. So I'm going to switch, this becomes 6 and 20. This is male. And this is 5 and 16, I believe, right? That's 16 female. Yep. So I'm switched your population around. So what happens to it? Can someone tell? What's the difference?
They just switched.
Yes.
Or actually, no.
Yes, you're correct. No, well, very correct. They switch around, and what else also switch around? Your sign is switched around. So first you have to switch your 2 numbers around. That means it will be 0.32 and negative 0.29. So you have to switch your 2 numbers around. And also your sign will be switched. So the 0.32 used to be positive, now is negative. And the 0.29 used to be negative, now is positive. Is that always like that, class?
Possibly.
Yes, the answer is yes. And it also worked for 9.2 and 9.3 for me. So that means that this is the third important, when you switch your population around, make sure that your confidence interval will be switched and your sign will be switched from positive to negative, negative to positive. You do not need to, if you want, you can perform it in your StatCrunch, but usually this kind of questions I will ask in your multiple choice question. So this is the third important thing that I would suggest you guys to write in your cheat sheet. Okay, so make sure you guys do that. So let's talk about this second important thing. So let's say you have a 0.05 significant level and you want to claim for P1 less than P2. What confidence level should we use here? So can someone tell me P1 less than P2, is that one-sided or two-sided test? Don't forget, two-sided. Is that, you guys remember two-sided is for what? Not equal, right? And one-sided is the left or right. So is this one or two-sided test? This is a one-sided test.
Oh, wait.
Okay. And for one-sided test, what is the formula we will use? Is 1 minus 2 alpha.
Okay, and for two-sided test, you said it was not equal.
That would be the next.
Did I?
Yep. So
okay.
So for this case, it's a one-sided test because it is P1 is less than P2.
But that means that it's not equal.
Yeah, if it's not equal, like the second example here, I will.
I see.
So
okay.
There are two questions here. So we are doing this one first, and then we're doing the next one. So for this one, it's a one-sided test. And so your formula is 1 minus 2 alpha, and alpha in this case is 0.05. So anyone has a calculator, can you help me with this? And this is your alpha here. This is actually is anyone? 0.9. So this is how you figure out your confidence level in this case. But for the second one, the second one is given us P1 not equal to P2. So is this a one-sided or two-sided test for this question?
Two-sided.
This will be two-sided. So, so in order for you to figure out what is the confidence level, you have to do 1 minus alpha, which is 1 minus 0.05. Anyone know what's 1 minus 0.05 is?
0.95.
0.95, yes. So if we are doing, last time we are doing the female is more than male. So actually it's a one-sided test. If I use a 5%, you have used 90% for your 0.9 as your confidence level. So what we did here is going to be wrong is because I used a 95. Remember I used 95 here. So it should be 90. You guys okay here? So my question to you is, I want you to read question 1 here. And can you tell me, is this is your claim here? Can you tell me, is this a one-sided or a two-sided test?
One.
It's asking for same proportion.
So two-sided?
Two-sided.
The two-sided, yes. Don't forget, same means equal, and you're doing not equal, so it's two-sided. And what is the formula to figure out confidence level is 1 minus alpha. So 1 minus, what is alpha in this case? Alpha is 0.05, so that's why it's so it's 95. That's what your confidence level in this case. 0.95. The reason why is because this is two-sided. Yep. So this is something that I would like to ask also in your test in the multiple choice. So make sure you guys got this one. Okay, very important. Okay. So what we are doing here is there are few things that you need to warning. If a question is asking us to test the claim, make sure you use the p-value method, which means that you use when you in your StatCrunch, make sure you use this. When we test the claim, don't use confidence interval. We use hypothesis testing. And when you use to find the estimate, or sometimes we use the confidence interval, make sure you use the confidence interval in this case. So like this question A, they ask you for hypothesis testing, then make sure you use the hypothesis testing performing. And then in question B, they want you to figure out the confidence interval, then you have to switch it to confidence interval here. Okay, so do not perform confidence interval for hypothesis testing and hypothesis testing for confidence interval. You guys with me here? So don't switch these two around. Okay. Don't test for equality for two population proportion. So what is going on for this second caution here is we can always figure out the female lefty, like what you did in chapter 7 and 8. And I do the male lefty for chapter 7 and 8. And I'm comparing, are they overlapping between these two? And we do not do this. The reason why we do not do this is because if you're doing a 95%, let's say you're doing a 95%, your confidence interval or your confidence is no longer 95 anymore because you're doing it twice. So it's 95 times 95. So if you take 95% times 0.95%, it's going to be less than 95%. So this is actually almost 0.9025. So when you want to find so you're no longer doing a 95% confidence interval, you're doing actually a 90% confidence interval if you're doing separately. So it means your confidence level is getting smaller and smaller if you do it separately. So that's why we do it together. So this is the same thing. So don't do separately in this case where you have two. And this is the one that we just talked about up here. If you have two positive, if your confidence intervals show two negative values, then P1 is less than P2. If they show both positive value, P1 is greater than P2. And if one is positive and one is negative, means it includes 0. It means that P1 and equals to P2. So this is exactly the one that we just talked about over here. When you have two negative, P1 is less than P2. When you have two positive, P1 is greater than P2. One negative, one positive, means it includes 0, means P1 is equal to P2. This is the same thing as the third one that we just did here. So don't just a repeat. All right. So let's do this. Okay. And question, this is a lot of work here. And then yes, and then we'll jump into your homework here. So what is the sampling distribution in this case? So in order for you to answer this, so this is talking about policemen, which is sad news about this week about shooting again. Just please class, do not go out there. Do not let me catch you, see me in the news that you are there protesting. Peaceful, yes, but don't go looting and don't do crazy stuff. You're in my class, you should be more professional. Don't do that. Okay, don't let me catch you guys doing that. So what is the sampling distribution that we have in this case? Because this is proportion. This is about how many, this is for people who don't, Kimberly. Don't do that, please. So this is talking about proportion. So your distribution in this case is Z distribution. Okay. So it's talking about so if you read this is talking about how accurate the shot, the policeman hit the target. So in New York City, 540 shots, 182 hits the target, and then 283 in LA that shots, and 77 hit the targets. So you want to test the claim that New York City police and Los Angeles have the same proportion, means do they kind of hit, the target almost the same? You cannot just look at a number. Oh no, they're not the same because 182 and 77, these are two different numbers. I mean, definitely they're not the same. But don't forget, New York City police has shot 540 times. For LA, only 283. So make that difference here. So so what you're gonna do here is, yeah, I'm gonna take points off. I'm gonna disown you if you guys go, if I see you guys there. So when you read this, the claim, can you tell me what is your population 1 and what is your population 2? Is population 1 New York or LA? If you read the claim statement. It's New York City, right?
New York. New York.
New York.
New York come first, right? So population 2 will be LA. So that's why make sure you guys read the claim statement over and over again. That's why I highlight in red. The one that comes first is always the first population. The one that comes in second is the second population. So so we're gonna do A here, which is hypothesis testing, 7 step. So first step is don't forget you have to do your requirement check. Okay. So is this simple random sample, and is your, if you have at least 5 success and 5 failures on both populations. So these are the 2 requirements that you have. So is this simple random sample? So again, you're looking for random sample here.
Yeah, the 540 shots fired.
Is this kind of random sample they got? Do they state it in the question that it is random sample here?
No, it's not sample.
No.
No, so this is not. Okay. So no, it has to be stated that this is come from a simple random sample, you know, something like it have to be in the question. So it's not there, so it's no. 5 success and 5 failures. How many shots? There are more than 182, right? This is one of them, and 77. So there are more than at least 5 success and 5 failures here out of, you know, these 2 groups. So this actually check, but unfortunately, your sim is not simple random sample, so the requirement does not match here. Okay, so so that's the reason why you still need to continue. So until you go on to the next statistic class, then you will learn another sampling distribution. You're not longer using Z after that once you do because of this case. So so the requirement isn't checked, but we'll still continue right now. So your null hypothesis, P1 is equals to P2 always, and then H1, P1 in this case now, because we are testing the claim that is having same proportion. Same proportion means that one is same means equal. So equal to, and the other one is going to be not equal to. You guys all right here? This is step 3, which is your Z distribution, which we got already. Step 4, you need to use your StatCrunch to do your work here. So so you will go to StatCrunch. Now we need to put in some numbers here. So again, this is for New York, this is for LA. So how many what is the number of success for this case for New York City? Got hit their targets. 182 and 540 shots was fired. And for LA is
77.
77. And how many they got fired? 283 shots, right? And you want to do a hypothesis testing, and you're doing equal and not equal. It's always 0. We always do 0 here. So because we move the P2 over, it's always 0 here. So this is the hypothesis testing that we're doing. And your test statistic is this, and your p-value is that. Okay, so I'm gonna. So your test statistic is sorry, it's a bit. 1.906, and your p-value is 0.0567. So this is step 4.
Step 3.
Step 3 is here, the z distribution.
Oh,
you're fine, don't worry about that. And then alpha is given us in the question, which is 0.05, which is right here. So now you have to compare between your p-value 0.0567 and 0.05, your alpha significant level. Is this number is less than or greater than 0.05? Alligators. Greater, yep. And if you remember, if it's greater, what is your conclusion?
Fail to reject.
So if your p-value is greater than your alpha, you will fail to reject H0. Yep. And in your test, do not just write fail to reject. This is, please pay attention here, because you can fail to reject H1. So please don't write this in your test. You will get half a point off. Make sure you put fail to reject the null hypothesis H0. Okay, and step 6, conclusion. So now the conclusion is based on, where's my conclusion? There you go. First, it's the same conclusion that we use, the box, the table that we have. Where was it? There you go. So, so if you look at this question, sorry, there's too many things open. Does this have equality? Does your claim statements have equality in this case?
Yes.
Your claim
Yes.
has equality, right? Because same means equal, they are the same. So since they have equality, which is now we're going to pick these two. And what do you tell me early on here? Do you reject or you fail to reject?
Fail to reject.
We fail to reject, right? So which one are we picking here? 1, 2, 3, or 4?
4.
The fourth one. Yep. So we are picking the fourth one. So this is the conclusion you need to write. There is not sufficient evidence to warrant rejection of the claim that da, 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 da. So your conclusion says that there is not sufficient evidence to warrant rejection of the claim. And again, I don't have time to type it. And the claim says what? Claim that New York City police and LA police have the same portion of hits. Again, so just copy and paste it up. You guys doing all right here?
So for number 5, you don't want us to. You want us to specifically say fail to reject H.
Yes. Yeah. This is more. Okay. This is your decision. This is very important. This is just, I'm just showing you why we pick fail to reject.
Okay.
Okay. Now what we did here is just for part A. Okay. Don't forget you got B and C. So that's why your homework, I don't assign a lot of homework here because you have to do all this. So in part B, you are doing the confidence interval. So the first thing you need to know is your confidence level. So this is your confidence level here. Since this is a two-sided test, so the confidence level is 1 minus alpha, and alpha in this case is 5%. So you have to use a 95%. So part B is very easy. You just need to put these two down, and then you just go to your option, add it, and then this is the same number. You do not just do anything with this. You just need to click to the confidence interval, and this is a 95% that we are looking for, 0.95. When you hit compute, and this is your lower, and this is your upper. So your answer in this case will be negative 0.00045. 0.1303, 0.4, something like that. So this is your confidence interval, your lower and upper limit. Okay. So C in this case is asking for, based on the result, does it appear to be a difference between the hit rate of New York City and the police office, NYC and LA? So in this case, in order for us to answer, is there a difference or not? You see if you capture 0. If you capture 0, it's no significant difference. That means no difference. If you have both negative and both positive, so what do we have on this case? Do we have both negative, both positive, one negative, one positive?
One negative, one positive.
So that means that that is no significant difference.
No significant difference.
Okay. So what you can say here is, since the confidence interval capture 0, there is no significant difference. And no significant difference means P1 is equals to P2. Okay, that is from the confidence interval. Now, if you also check the hypothesis testing from the hypothesis testing in part A, don't forget we did hypothesis testing in part A. One is for part B, one is part A. What does that mean when you say there is no sufficient evidence to warrant rejection? So these two are actually what?
Negative.
Negative and negative. So they're canceling each other off. So that means that LA and New York City and LA policemen have the what? Same proportion of hits. So from this, you can tell that P1 is also equal to P2. This one says P1 is equal to P2. So what I want to point out to you here is these two part A and part B give us the same answer?
Yeah.
Yes, and it has to be. I just want to point out to you.
So in the test, do you want us to write both the
Yep.
Okay.
Because this question is asking for on the results, it means they're asking for A and B. And how do we do A and B is you just figure out if A is P1 is equals or less than or greater than to P2. And then part B, you just look for this case, are they both positive, both negative, or one negative, one positive? And they should match. They should match. So if one say P1 is less than, one say P1 is equal to, something is wrong. I just want to point out to you.
So what if for part B it's a positive and an, oh well, no, I guess it wouldn't.
Yeah, it cannot be positive and negative, it should be negative or positive. Yeah, cannot be. Yeah. Yep. So make sure you note. So I want to point. So now, does there any difference? The answer is there is no significant difference. So the answer is no significant difference. That means that New York and LA policemen, the hit rates are all the same. Are you guys okay here? Is this tough?
Yes.
It is. I didn't say it's easy because you got to do both of this, and there's a lot of referring to all this stuff that you have. So I'm going to take attendance now. Can you guys please present? You know what to do. Attendance time. So let's take a look at your homework. As you know that I don't assign a lot of homework in chapter 9.1 because that's how. And let me 10 questions here. And again, this whole thing in your test worth like 14 points. This is already worth like 7, 8 points already. And then this is like 2, 3 points. And then this is 2, 3 points. So if you want to do part A, B, C here in your test, this whole thing worth around like 14, 15 points. So do not screw this one up because it's a big point here. Okay. Let's take a look at your homework. This is just asking for requirement check. So you just need to read the requirements. So there are 2 requirements, simple random sample and more than 5 success and 5 failures. So in a clinical trial, this many children is randomly to assign to two groups. One of them is given a vaccine for polio, and the other almost half give a placebo. Among those 133 develop polio, those who get the vaccine, and 115 who get the placebo develop polio. We want to see, so do we fulfill the requirement here?
Yeah, it's A.
It's random sample, and that's more than 5 people in each group. So in this case, your answer is A. I don't know, A, B. We don't use 1,000.
Oh, sorry.
Yep.
It's not-
There
it's
has to
not
be at least
1,000.
5 success and 5 failures. Okay, we don't use 1,000 here. You guys all right? The first one is a bit easy, so just asking for requirement check here. Okay, now they're asking for this. So again, this many people assigned to two groups. This many children get the vaccine. 35 got the disease, and these people get the placebo. Consider the vaccine treatment group to be the first sample. So that means the vaccine is population 1. So can you tell me what is N1 in this case? That means the children who receive the vaccine.
199,507.
Yep. Out of these people, what is the proportion of getting this disease? So how do you figure out P1? So if you refer to my notes, P1 is found by taking X1 over N1. So what is X1 and N1?
$35.
So X1 is, how many people got 35 out of what? This many people, what?
199,507.
199,507. So calculator, make sure you divide this. 35 divided by that. 199,507. You get 0.123. 1, 2, 3. Right? Yeah. And then 175, something like that. Is that what you guys got?
Yeah.
So they want in 8 decimal places. It's not enough. Can you believe they want 8 decimal places? So 8 decimal place. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So that is your answer here. So you just make sure you put in 8 decimal places.
Just to clarify, you're not going to have us do 8 decimal.
Well, because this number is so small, that's why they want you to put 8 decimal places.
I know, but I mean for the test.
No, in the test, I will give you a bigger number. So
Mm.
mostly it's 2 or 3. So
We
you won't get.
appreciate that. Thank you.
You won't get 199,507. No. You will get a smaller number. How do you find your Q1 hats? You just 1 minus this. Okay. So in order for you to find the Q1 head, you take 1 minus what you have from there. So you take your calculator, take -1, and this will give us 0.8 decimal place. 1, 2, 3, 4, 5, 6, 7, 8. So 999,824,57. So you just, that means when you add these two numbers up, you should get exactly 1. Okay. And you do the same thing for the second group. So the second group is 250. And then same thing, you divide this 126 with this icky number, 126 there by 200,250. Oh my God. Again, 8 decimal place, 0 0.1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah. 1, 2, 3, 4, 5, 6, 7, 8. And then they ask you for Q2, again, 1 minus that follow. So this is repeat. 4, 5, 6, 7, 8. Now they want you to find this. Now this is the one that I would not like you to I wouldn't ask you to do, the P bar. So how do you figure out P bar in this case is you have to use the formula that I do not want you to memorize. This is how you do your P bar. P bar in this case is x1 plus x2 over by n1 plus n2. So this is how you figure out P bar. Again, it's not coming up in your test, so don't worry about that. x1 plus x2, and then over by n1 plus n2. So if you read this question, x1 plus x2 means the total of people got disease. So 35 on the first one, and 126 on the second one. And then n1 plus n2 means the total, which we know is 399,757, which is the same thing by adding your both n1, this 199 and 200,000. If you add this, you get this 29. So if you got this, this is your answer here. Just add and divide. 35 plus 126 divided by 399,757. And I bet they won in 8 decimal place again. Yep, 8. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8. And then they want you to find Q bar. Q bar is the same thing as 1 minus whatever you have. Same thing we do the Q. So you just subtract 1 from your answer. 0 0.1, 2, 3, 4, 5, 6, 7, 8. 6 will be, so 6 and 4. Yep, 6 and 4 give us 10. You guys all right here? So don't worry about question 2 because I won't ask you to find the P bar and the Q bar. But mostly all this you really know how to do it. It's just, again, the question is a bit wacky because of very small numbers. So this one has a technology result. So you just refer to your technology result. And this is your confidence interval, and this is your critical value and your p-value. So you do not need to use StatCrunch to run through it. So I'm going to go through something that you have to use a StatCrunch to do it. This one doesn't. Yep, you're gonna. This one is very tricky. Your online homework is very tricky. So so 2017 cars in particular region. 223 has real license, and then 377 trucks, 52 have real license plate. So we want to test the claim. Look at the claim says what? That the commercial truck owners is higher rate than the car, passenger car. So by looking at this, can you tell me what is your first population and what is your second population? This is very tricky. Now, if you read this, in the test, I wouldn't tell you to use, but if you read the question A here, they want you population 1 as what? Passenger car. And population 2 is the commercial truck.
Picture 23. the car.
And if you look at your hypothesis testing here, this is so tricky. What is your H0 and H1? So H0 is always P1 minus P2 equals to 0, or you can say P1 equals to P2, doesn't matter. This is the one, the H1. You want the truck owner's truck having higher rate than cars. So how do you write this? Don't forget, P2 is truck, P1 is car. Truck means
So
P2, right?
P1 is
P2
less than P2.
is greater than P1, right? Because truck is P2,
Mhm.
car is P1, higher rate means greater. But since if you look at our hypothesis, P1 always comes first, then P2, not this. So you have to swap these two around. Do you know what happens if you switch your P1 and P2 around here? What happens to your sign?
That switches.
You have to switch it. So this is tricky. The reason why it's tricky here is because of, although this is a higher rate, a lot of people think higher means greater, but the tricky part is because they flip your trucks and your cars. You see that? So they are very tricky. So be careful in this case. So your answer in this case should be B. One is equal and one is less than. Okay. Now we go to your StatCrunch to put in some, where's my StatCrunch? So StatCrunch is here. So let's do some, so it's under data, stats, proportion stat, to sample with summary. Don't forget, P sample 1 is car. So how many cars that has real license plate? So for cars have real license plate is 223 out of 2017. And for truck, 52 out of 377. And we want to test P1 equals to 0 and the equal, and the other one is less than. So make sure you use the less than symbol here. So this is your answer. So for your test statistic in 2 decimal place is negative 1.53. And then the p-value will be next. They will ask you to do. P-value is the last one in 3 decimal place, 0.063 or everything. So 0.063. And then now you figure out is your p-value and your alpha. So what we have here is my p-value is 0.063. That's my p-value. And my alpha significant level is given us by what? It should be 0.01. So can someone tell me, is this?
I have it's greater than, but I have a question about the p-value.
And let me finish this one and then we'll answer. So if this one is greater than that, we will fail to reject, right? H0. So that means your answer is either A or D. You fail to reject.
Not
and when you fail to reject, do we have the conclusion now? Do your claim statement has equality or no equality? Since we are doing higher or less than here, so does that have equal or no?
No.
So your claim has not equal sign. And you fail to reject H0. This is the 2 things that you need to combine. So now refer to your table here. Which one should we pick?
the second one.
Second one, because we doesn't have equality and we fail to reject. So that is not sufficient evidence to support the claim. So the second one is the one that is correct. So fail to reject, that is sufficient, but that is not sufficient evidence to support the claim. Right? The second one. Not sufficient support the claim. So this is that.
Not.
All right, now who has question just now?
Okay, so in terms of the p-value, when you're doing greater than, when you're measuring the
This one?
like part 5, yeah. So what does it mean? What does the p-value mean when you're looking at two different sets of, when you're
So
comparing?
what happens is the alpha is here. This is 0.01. However, your p-value is here. 0.063, which is, that's why this area is greater than. So that means that you will have to fail, because this area cover more than that. So you have to fail. Krista, yeah, you can go. If this area, if this is your p-value, if p-value covers more than your alpha, you will have to fail to reject your null hypothesis, because your p-value is higher than what we expected.
So in terms of what it means, like, well, I like that explanation because it makes sense. But when you have two sets of data, so like you have one percentage for cars and 1% for trucks, what is, when the p-value is combining both of them?
Yeah,
both
this
of
is,
those
yeah,
percentages?
yep, this is, you're correct. This p-value that you found is these two together. We're not doing separately. So we're doing these two together, we're comparing these two together at the same time. Yep.
Okay.
Yep, this p-value is comparing those two together. Yep, that's why we are doing, so that's the reason why that we are doing two proportion stats here in your StatCrunch.
So P1 minus, okay. I don't know.
P1
It's
minus P2 is less than 0, or you can say this. So again, there are two ways to write it. Doesn't matter with me. Okay. And then for the last one is, before you continue with this, you in part B, you have to figure out what is the confidence level. So how do we figure out the confidence level? Is first thing first, tell me, is this a 1-till or a 2-till test?
1-till.
This is 1-till test. Yep.
Question mark.
If it's 2-till, it has to be not equals to. Okay, this is 2-till.
Okay.
And if it's a 1-till test, if you refer to here, 1-till test, one-sided test, it is your confidence level is 1 minus 2 alpha. And what is alpha in this case? 0.01. So in this case, is 1 minus 0.1 minus 2 times 0.01, which is what?
0.98.
0.98. So this is the confidence level you need to use. So what you do here is go to your StatCrunch, go to the option, edit it. Now you just need to, same thing, move it to the confidence interval and change it to 98. And this is your answer here. Your lower limit in this case will be this number, negative something. How many decimals? 4 decimals. 718. 718. And then for the height, 0.0170 is 4. Yep. And now they're always asking us is, do this confidence interval, does this confidence interval capture 0 or not capture 0? One is negative, one is positive.
Mm,
Does it capture 0 or not?
yes.
Yep, it
Yes.
captured, yes, it captured 0. Okay. So what does that mean if it's captured 0? So
There's
if it
no
ref-
significance.
Yeah, yep. So if it's including 0 or capture 0, no significant difference, P1 equals to P2. So there is no significant difference between the two population. So there is not sufficient evidence to say that this is higher than that, because our question should be, we should say P1 is equal to P2. But so that's why. And this conclusion is not sufficient evidence. It's the same conclusion you make here, where you say that is not sufficient evidence to support the claim. See that? So this and this should match. Okay, so this and this, as I mentioned before, these two has to be the same. So please, so yeah, it's a bit tough. I didn't say this is easy, right? And this is worth a lot of points in your test. So that's the reason why that you guys have to, your homework for this coming week is 9-1. And then, and once you got this done, like, you know, really good, and then 9-2 and 9-3 is kind of the same, but we're doing new. So I would
We're
recommend.
gonna do chapter 10.
Yes, 10 is only 2 sections, 10-1 and 10-2, and that's it.
Okay.
So 9, so you got like 5 more homework left. So 9-1, 9-2, 9-3, 10-1, and 10-2. So I would
When is
recommend
the final?
the final. If you look at the syllabus, I think it's on May something. Let me see the syllabus here. Sorry. You guys have my syllabus, right? Final is on May 12th, the Wednesday.
Is there any extra credit?
No, there's no extra credit. So this is your finals. It's from 1:30 to 1 o'clock to 2:30. It's a 1.5 hours. It's the same, same format. You got 10 multiple choice question and 4 to 5 open-ended questions. The same thing that you did in your midterm. The same format, but it will cover 7, 8, 9, and 10.
Okay. Do you have any times where like you can meet up like you're like on Zoom?
Yes, you just need to email me and we set up a time.
Okay. Thank you.
So if you guys want to do a one-on-one Zoom, you just need to email me a time. Don't just say, I want a one-on-one Zoom. Just give it, I want one-on-one Zoom with you. Give me a set of time. Thursday, this from here to here. Friday from here. Give me a time frame. So
Well, you're not free every day though, right?
yeah. So that's why I give me a time frame that you're free. Don't give me just one. Give me a 2, 3 time frame. Then I'll pick one and I will set it up for you.
Okay.
Yep, make sure you guys do that. Yes, this is very tough, as I mentioned. This is a lot of readings and a lot of like you're doing 2 things again: confidence interval and hypothesizing in one question, and you got two populations here. So that's why it takes a little bit more time to do it. I didn't assign a lot of questions here because it, as you know, one question takes you, a lot of work going on, but they all are all the same. The same format. So make sure you guys understand how you use a StatCrunch on here, and then how you're answering your questions in this case. All right, I'm going to stop the class today. Stop recording. Does anyone have any questions for me? If you have no questions, you may go, but if you